Hey, good morning, everyone. Thanks for joining our webinar this morning. We have Bill Rodeman, Electrical Program Manager from Land O'Lakes, here this morning with us. He'll be talking on electrical safety program development. So without delay, I will turn it over to Bill. Bill, it's all yours, so go ahead.
Awesome. Thank you. I'd like to welcome everybody. Thank you for tuning in. Wanted to get together a little bit and talk some electrical safety, specifically around building and developing an electrical safety program. Again, I'm Bill Rodeman, Electrical Program Manager for Land O'Lakes. I've been responsible for the development and implementation of the electrical safety program for Land O'Lakes, pretty much across the entire enterprise, all of our manufacturing facilities, multiple divisions, multiple sites. So trying to create something that we're able to actually spread out across the entire organization it's been a challenge, and there's certainly been some learning. So hope to share some of those learnings with everybody here today. Prior to that, I spent the first, I don't know, probably 15 years of my career actually on the floor working in food manufacturing facilities as part of the maintenance department. All that was pretty on the floor, hands inside equipment, trying to troubleshoot, improve, fix, whatever it is, hands inside the equipment. So I try to take a lot of those experiences and then kind of relate those back to some of the requirements that I try to put in place. So hopefully they relate a little bit easier to the people that we're really trying to protect that are actually exposed to these electrical hazards. A lot of the times I try to get back to the basics, get back and give them the basics that they need so that they can kind of take it from there and run with it. And a lot of times, once you get back to the basics, you're really looking at, okay, why are these requirements in place? What are they doing for you to be able to make sure that you can actually do your work safely? So with that theme, starting with the basics, I like to pose a question to everybody listening here. What is the purpose of the electrical safety program? And just take a moment to really think about it, because a lot of times people look at the electrical safety program and it's a list of requirements. I got to fill out paperwork. I got to put this on. I got to do this. I got to do that to make sure, and that's what's required by it. But creating a list of requirements really isn't the purpose of the program. The purpose of the program, in my eyes at least, is to really help guide the increase in knowledge of electrical safety. What can you do as part of the program to help everybody understand electrical safety better and the role that they play in electrical safety? Because each person's going to have their own hand. How can you make sure that they understand the part that they play? And once everybody understands the part that they play, that's going to build into the culture, and how can you actually further the development of your electrical safety culture within your organization? Now, this can also be applied depending on your organization or your facility. This could be across an entire enterprise, such as what I'm primarily going to be talking about, but you can also take this and scale it down to just a single facility. If you work in a facility and you're trying to implement something like this, it's the same kind of thing. It's just going to be on a smaller scale. So topics today, we're going to take a look at some of the requirements for an electrical safety program. From there, let's take a look at some of the key elements in an electrical safety program. From there, once we have the program developed, let's look at execution, communication that's going to be coming along with it, what type of planning needs done, the review process to make sure that we're actually improving our program moving forward as well. So first, where do we even go to find requirements? If you look over to the right-hand side, you're going to have OSHA and NFPA 70E. On the top there, you have OSHA, the Code of Federal Regulations. That is law. That is what you have to follow. On the bottom there, you have NFPA 70E, which is the standard for electrical safety in the workplace. That is the consensus standard for really the best way to protect employees from electrical hazards in the workplace. If you look at OSHA, or the Occupational Safety and Health Association, I like to say that if you think OSHA is a small town in Wisconsin, then you're probably in trouble. OSHA, that is the governing body that it creates the regulations. That is, again, what you have to follow. The first step in understanding the OSHA regulations for what applies to you, you have to understand which industry you actually fall in, or which section of the OSHA standard that you need to go to. I have a couple of them listed here. Title 29, the Code of Federal Regulations, or CFR 1910, that applies directly to general industry. If you're working in a manufacturing facility, such as what I'm used to for food manufacturing, general industry is what applies to us. If you're working in construction, you're going to go to the section 1926. If you're working in agriculture, it's 1928, and it goes on and on. If you're working in maritime, if you're a state or federal employee, there's different sections. So you want to make sure you're looking at the section that applies to you and not to one that applies to another industry. From there, within that section, you're going to need to find the part of the section that deals specifically with electrical safety. If you're in general industry, you're looking at 1910, 301 to 399, which is known as subpart S. That's going to list all the electrical requirements that apply to general industry. If you're in the construction industry, you're going to be looking at 1926, 400 to 449, which is known as subpart K. NFPA 70E, or the National Fire and Protection Agency, their standard 70E. That is the consensus standard of what's agreed upon as really the best way to protect employees in the workplace from electrical hazards. That is updated every 3 years. The current edition is 2018, so if we do some quick math, we realize that 2021 is going to be the new edition. They are making those updates, and look for that coming out here the end of this year, beginning of next year. There's going to be some new updates, so be sure to keep an eye out for that one. When we're looking at that, there's often quite a few questions asking about, okay, what's the differences? How do they play together? What do we need to know from each of these? One way I like to break it down, OSHA is going to tell you kind of what you have to do. Regulatory, this is what you have to do. NFPA 70 is going to give you a little more on how to actually do that, how to keep people safe. So as an example, if you look at OSHA 1910-335 A1V, dealing with head protection, it says employees shall wear protective equipment for the eyes or face whenever there is a danger of injury to the eyes or face from electrical arcs, flashes, flying objects resulting from an electrical explosion. So pretty much it says if you can be hurt, you got to protect the head and face. Okay, well, it doesn't give you a whole lot more there. I mean, you could put on a big old metal knight's helmet, and that's going to protect my eyes and face from an explosion or from flying objects. But I think everybody listening can probably agree you don't want to wear a big metal knight helmet when you're working around electrical equipment. If we move over to NFPA 70E, looking at their Article 130, C3, it talks about employees shall wear non-conductive head protection whenever there is a danger of head injury from electrical shock or burn. So again, now pretty much that's saying your night helmet no longer works. You got to wear something else that's non-conductive. So it gives you a little bit more there, but it also says later in that paragraph, if employees use hair nets or beard nets or both, these items must be ARC rated. Well, that specifically resonates with me coming from the food industry because hair nets and beard nets are part of our everyday daily wear. We wear those all the time, and it's a great call out that those are items that have to make sure that they either come off when you're doing this type of work, or if you have to wear them or are going to wear them, that they've got to be ARC rated. So it's another call out, giving you a little more on how to actually protect your employees. Then a little later in that article, Article 130 C10B1, an ARC rated hood or an ARC rated balaclava with an ARC rated face shield shall be used whenever the back of the head is within the arc flash boundary. So if I'm working on a piece of equipment and the arc flash is potentially going to be large enough to actually engulf the back of my head, I want to make sure the back of my head is protected. If I'm wearing a standard face shield, it's only going to come to the sides. And if I actually become engulfed in the flame that comes from it, the back of my head will receive a burn. Well, here in this section, it's saying make sure you wear your ARC rated hood that has the back protection with it, or make sure you're wearing your balaclava underneath your face shield with it to make sure that the back of the head is protected. So again, it's giving you a little more on how to actually protect employees. So kind of moving back to some of the basics, we saw NFPA 70E and OSHA. That's where you go to find some of the requirements. But when you're looking at your electrical safety program, again, what are you actually trying to protect against? What are we trying to protect employees from when it comes to electrical hazards? When there are two direct hazards when it comes to working on electrical equipment. So we're going to want to make sure we're protecting people from shock and arc flash. So those are the two direct hazards when working on electrical equipment. First, looking at shock, shock is defined as any time current is passing through the body. So if I have current that actually goes through my arm, I receive a shock. When you're looking at the severity of a shock, there really are three factors, and this is straight out of 70E. You're looking at the magnitude of the current. The more current that actually flows through my arm, the more severe the burns are potentially going to be inside my arm. Therefore, the more severe the shock's going to be. Time duration, how long current's flowing through my arm. The longer, the more severe the burns are going to be. Now, when we talk about the time duration, a lot of times we're not talking about something grabbing and holding on purpose. There's a phenomenon as current actually flows through your arm. If there's enough current, it could actually make your muscles contract, potentially making you grab onto something. So say this is an energized highlighter and I touch it and there's enough power going through my arm, I could actually potentially grab on and not be able to let go from this energized highlighter. It's often referred to as being hung up. Now, a lot of times when people are going through and first learning on it, instead of, they teach you, touch it with the back of your hand. That way, if something actually comes through and you contract your muscles, it's actually going to pull you away from that. You're not going to be hung up from it. The third factor is the path that the current actually takes through your body. So if I touch something energized and ground my elbow, and the current goes up my arm and out my elbow, that is a less severe path than if I touch it with one arm, touch it with the other arm, the current goes up my shoulder, across my heart, and down the other arm. Because it crosses your heart, that's a more severe path because it only takes less than 1/10 of an amp across your heart to actually mess up the rhythm of your heart and send your heart into ventricular fibrillation. Once you go into ventricular fibrillation, you have to be hit by an AED to restore the rhythm of your heart, or you die. So that's why the path that the current actually takes through your body is one of the critical factors in the severity of a shock. Arc flash, I define arc flash as a rapid release of energy due to an electrical fault. If you want to find a more detailed definition of it, you can certainly do a Google search on that, look at Wikipedia, there's a lot more information. A lot of times they talk about the plasma that's actually generated and discharged from it, how current actually travels from phase to phase through a normally non-conductive media such as air. I typically try to relate an arc flash to an explosion. So I try to keep my definition fairly simple, but really I relate to it as an explosion because when you have an arc flash, you're going to have heat that's generated, you're going to have a pressure wave that's generated, and you're going to have shrapnel that's actually expelled from the equipment. So when I explain it as an explosion, that's what most people think about, and we're able to then kind of relate that and make sure that they're taking the proper precautions into account. Arc flash, typical causes are going to be either equipment failure, or more often than not, it's going to be human error. Somebody's in there doing something they're not supposed to, or they're doing work that they're supposed to be, and they do something unintentional, whether they touch something they thought was de-energized that isn't, they're in there working and they drop a tool, something happens, and due to human error, they actually cause the arc flash. Incident energy, an arc flash, the amount of energy that's released, the amount of energy released from an arc flash incident is known as the incident energy, and that's measured in calories per square centimeter. So calorie being the measurement of heat that's actually expelled, and if you take a 1 centimeter square, that's how much heat's actually going to hit that 1 centimeter square. So that tells you how much is really going to hit you. Typically, we're looking at it in the chest and face. The two factors in how much energy is actually released, or the two biggest factors really, are going to be the amount of current that's available there, your fault current, how much current can actually hit that piece of equipment, and then the time duration, how long does that arc flash last? So if you look at your electrical system, wherever your arc flash is, if you go upstream to either your breaker, your fuse, your relay, however long it takes to trip and stop feeding current there, the longer the arc flash lasts, the more energy that's actually going to be expelled during that arc flash. Okay, so now we took a look at where to find some of the requirements. We took a look at some of the basics of the electrical hazards. Okay, what is required to actually go into an electrical safety program? Well, if you look into NFPA 70E, Article 110, that is, the title of the article is General Requirements for Electrical Safety-Related Work Practices. I like to look at this because a lot of those safety-related work practices are really what needs to go into your program. So I look at this as what should actually go into an electrical safety program, is what's actually included in this article. And the very first sentence of the whole article, 110.1a, an employer shall implement and document an overall electrical safety program that directs activity appropriate to the risk associated with the electrical hazards. So you got to make sure you understand the hazards, the risk associated with the hazards, and make sure you direct the right activity appropriate to that risk. It then goes through and lists a whole bunch of different elements that you can take and make sure are part of your electrical safety program, such as inspection, condition of maintenance, risk assessment, job planning, how you're actually going to investigate your incidents, training and auditing, how you interact with contractors, and then all the way in the back in the informative Annex E, it's titled Electrical Safety Program. They actually have a lot of typical principles, controls, and procedures that you can go back, take some of those and reference them and bring them into your electrical safety program as well. So here is how I break down my electrical safety program. Here are the key elements that you have. You have your overarching program, and as part of that program, kind of supporting it, you're going to have some of these different elements to make sure you're focusing on. I look at qualifications. What qualifications do my people need in order to be able to or be permitted to do this work? What type of assessments I'm going to be doing on my equipment and my tasks? What type, once I understand the hazards, what am I doing to actually protect employees? What protection strategies am I putting in place? Then what kind of job planning am I doing? And then how am I maintaining my equipment? When I kind of looked at this and I said, in order for somebody to perform this work safely and do whatever these tasks are, we want qualified people working on equipment that's been assessed and the hazards are known. They have the right equipment, PPE, and protection strategies in place for those hazards. They're properly planning the work that they're going to do, and the equipment's been properly maintained. If you meet all that, you really should be able to do this work safely. So that's how I broke down the program. So looking at qualifications, NFPA 70E, they define a qualified person as one who has demonstrated skills and knowledge related to the construction and operation of electrical equipment and has received safety training to identify the hazards and reduce the risk. So I look at that, it's really a two-part definition. First, you have to have demonstrated skills and knowledge, and you have to receive training. Or you can look at it, you got to be trained, and you have to have a demonstration. You have to be trained, you have to be audited. Your audit's really going to be your demonstration of skill. They also have in Article 110.2 A1B, it states that a person can be considered qualified with respect to a certain equipment and tasks, but still be unqualified for others. That's typically referred to as a task qualified person. I have someone who they've been trained and they're qualified to perform this task or work on that piece of equipment, but they're unqualified to work on this one. And that's really something that as you look at some of the tasks or jobs or equipment in your facilities or within your organization, that's something you can really try to leverage as well. Maybe we don't need to train this person on all this equipment, but just the one that applies directly to their job. So when you're looking at that, what are your qualification requirements? So again, we're going to be looking at your training and your auditing. When you're looking at training, how are you going to deliver the training? What is the frequency of the training going to be? And how are you actually going to track a lot of that? We took a look at it and, okay, are we going to deliver the content or deliver the training with internal personnel that's able to do the training? Are we going to partner with a vendor that's actually come in and do a lot of this training for us, for our personnel? Or is there some sort of online platform we're able to leverage? And we actually kind of used a combination of all three, where I'm able to go through and do some of these trainings as well. We have outside vendors that do trainings for certain facilities. Maybe I'm not able to get to or their schedules don't line up. We also have an internal learning management system that we do a lot of different training for everybody across our organization that we're able to then use that to get some of these trainings and also help track these trainings as well to make sure we're actually able to keep track of who needs what training when. When you're looking at frequency, NFPA 70E states that retraining shall be performed at intervals not to exceed 3 years. So a lot of people look at that and they say, okay, you need refresher in 3 years. Well, as I started looking at that and the overall number of people that actually have to take this training, that was going to turn into an absolute nightmare to try to manage. There's just so many people. And what was it this year? Is it next year? Was it 4 years ago? When was that done? So we just said, you know what? We're going to train everybody every year. You're going to take refresher training every year, and we're going to move along that way. It took a lot of the, it was made it easier to manage. We just reassign it, and then at any point throughout the year, you can go ahead and take the training, because if you take it on January 1 of one year, and you go until December 31st of the following year, you still took it within that year, so it meets our requirements, and it's only 2 years apart, which meets 70E requirements. So that was something we looked at to try to make the management of this training actually a little bit easier on us. When you're looking at the audits, looking at frequency, NFPA 70E says that interval should be performed at intervals not to exceed 1 year, so that every year you have to make sure that people are doing these audits. What tasks are you going to be doing for these audits? Look at tasks and equipment. So we looked at, okay, what type of equipment's actually common in a lot of our facilities, and make sure that you're doing an audit based off of those types of equipment. We looked at breaker panels, MCC buckets, control cabinets, local disconnects, other items similar to that that people are going to be getting into. And instead of doing every breaker panel in the whole facility, okay, you did one, you demonstrated that you understand how to do the job safely and how the equipment actually operates to pull the cover off, to get into it, and what it takes to do that. So we looked at the tasks and the equipment, and then you got to look at who's actually going to do your audits. Is this, again, something you're going to partner with an outside vendor? Do you actually have the personnel internal to your organization that are able to actually perform these audits? We created an auditor training to be able to get internal personnel able and up to speed on how to actually conduct these audits ourselves. Looking at assessment, identifying the hazards at a facility. One of the best ways to identify the initial hazards is to do a power system study. This is often referred to as an arc flash study or an incident energy analysis, but that's really only one part of it. I have 3 elements listed here, the arc flash study, short circuit study, and coordination study, but there's so many other elements that can actually be incorporated here when you're looking at motor transients, load flow, equipment evaluation, everything like that. There's a lot of different elements you can look at, but these are really 3 of the main ones. When you're looking at the arc flash study or the incident energy analysis, it's going to say, okay, each piece of equipment in my system, if an arc flash happens there, here's how much energy is going to be released, and here's how far away you need to stand in order to not be burned. When you're looking at the short circuit study, if I have a piece of equipment and a fault happens there, how much current's actually going to hit that piece of equipment, worst case scenario. And so you're going to need a lot of that information, or at least how much current's available for your arc flash study. But then you can actually take that and bring it back to compare the amount of current that's actually available to how much your equipment's actually rated for. What you want is, I have 15,000 amps available to this piece of equipment, and it's rated for 30,000 amps. Okay, your equipment's actually going to be able to withstand that. What you don't want, and sometimes you'll find, is my equipment's rated for 30,000 amps and I have 50,000 amps available. Well, now, if a fault does occur and you have that 50,000 amps come, the equipment's not rated to handle that. And when we say that, the actual fasteners that hold the equipment together is not able to handle the magnetic forces and everything that comes with that much current, and it's literally going to rip itself apart. So you're able to then identify those and either look at ways to reduce the amount of current or to replace the equipment. Coordination study, if I have a fault occur at a piece of equipment, which breaker is actually going to trip first to stop it? You really want the one directly upstream to trip. If I'm working inside a motor control center and a fault happens, I want the main feeding that motor control center to trip, not the main feeding the building. You want to shut off as little as possible, so that'd be identified during the coordination study. Once you identify the hazards, now you need to look at the tasks that are being performed and do a risk assessment based off of those tasks. Okay, I know the hazards that are there. Here's the tasks. What's the likelihood of an occurrence, and what's the severity of the event? So do an actual full-blown risk assessment based off the hazards you're going to be doing. Once the hazards and the hazards are known and the risk assessment's being done, what are my risk control strategy? So here's a picture of the hierarchy of risk control. As you move up this triangle, these protection strategies become more effective. When you get to the very top, elimination, if there are no electrical hazards at all, that's the most effective. There's really no human error that can cause something. If you completely eliminate the hazards, then that's the most effective means. And as you travel down, substituting the hazard with a safer alternative, engineering controls. What do you need to do to apply these engineering controls to engineer out the hazards or make the equipment safer? Awareness, which is training and signage to make sure people understand the hazards. Everybody's favorite, administrative controls or different paperwork. Now, again, as you get into kind of some of these bottom ones, they're the most susceptible. They're really reliant on the person, and they're the most susceptible to human error. Paperwork, it's really easy to pencil whip a document. Now, a lot of documents are very effective when they're done properly, but again, it's going to rely on the person doing it. When you're looking at PPE, it's the last line of defense, but it's also the most susceptible to human error. You got to make sure that one, you got to wear the PPE. If you're not wearing the PPE, it's not going to do you any good. You have to be wearing the right PPE. You have to be wearing the right PPE the right way. You got to want to make sure that your gloves are actually on over your cuffs or over your sleeves. You got to make sure that your shirt's actually buttoned all the way down. It's actually tucked into your belt. When you're wearing your balaclava, that's actually tucked into your collar and not sitting on the outside. So if you hit with an arc flash, it doesn't travel directly up underneath your balaclava to your neck and face. So you have to wear it the right way, and you got to inspect it to make sure that it's not actually damaged. So again, it's effective, but it's only as effective as the person using it. So as you go through and identify these, make sure you're actually leveraging these control strategies. And I mean, PPE may be at the bottom of the list, but make sure that the proper PPE is available, the right insulated tools, the right test equipment's available at these facilities, and that there's a way to actually track that. Okay, yes, I do have it, and it's been verified that I actually have all this equipment. So what are you going to do to make sure that that's actually there? Job planning, making sure that you're documenting the tasks being performed and identifying the hazards before any work begins. This is probably one of the biggest keys, in my opinion, to working safely, is to try to get yourself in the right frame of mind. What am I planning on doing? And what are the hazards associated with that? Well, now you've thought about what you're going to do, so you're less likely to make a mistake. And you've thought about the hazards and how to protect yourself from those hazards. So even if you do make a mistake, the proper protection strategy should be in place. So that's my thought on it. And NFPA 70E lists two different types of documents. The job safety plan, it goes by a lot of different names, the job hazard analysis, job safety analysis, really anything to actually document your plan, the tasks you're going to do, and the hazards associated with it. And then they list the energized electrical work permit. Both of these, both of them require the completion of a shock and arc flash risk assessment, where you're actually documenting what the hazards are and how you're going to protect against them. The job safety plan is really more there for the person to go over the tasks and the hazards. The energized work permit is really there. So the job safety plan we require for really anytime you're exposed to an electrical hazard, you fill them out. I tell everybody, you're going to fill out a pile of these. If I come back in a year, you should have a pile of job safety plans from all the work that's been done. Anytime you're exposed to a hazard, you got to fill one out. When you're looking at the energized electrical work permit, that's really for performing repair work or making physical changes to energized equipment. So an example I like to give is if I go through and I find that a contactor inside a piece of equipment's bad and it needs replaced. If I'm going to leave power on to that contactor, which I don't know why you would, to pull it out and put a new one in, you have to have an energized work permit. And that's going to go over justification for why you're not going to turn it off, your shock and your arc flash risk assessment, other safety related work practices you're going to follow, and then also approvals from others because you're actually doing that repair work or physical changes while the power's on the equipment. And lastly, reliability. Reliability really, it's ensuring that electrical equipment's not beginning to degrade to create additional hazards. I want to make sure that we're maintaining equipment. We don't want equipment that just it sits there and you go over to turn it on and something internal breaks because it's literally been sitting there for the last 10 years and nobody's ever opened it up or even operated it on and off. And how do you want to maintain your equipment? According to either manufacturer's recommendations or industry standards. When we say industry standards, we're referring to NFPA 70B, the recommended practice for electrical equipment maintenance. or the NETA MTS or maintenance and testing specifications. Both of these are going to go through and actually list different types of equipment and the recommended practices, preventive maintenance, predictive maintenance, whatever it is in there on what should be done for each piece of equipment. So now we went through, we took a look at, okay, we have this many, we have where to go to find the requirements, the basics of electrical hazards. We actually have our program developed for what we want to do. Now, how do we actually get the program in place? First, you're going to have to look at your communication. Second, you got to look at your communication. And third, you probably guessed it, you got to look at how you are communicating. And I know that's not really an earth-shattering concept. In order to put a program in place, you have to communicate it. But it's really the most important factor in how the program gets put in place, and you're pretty much your success for implementing it really depends on how you communicate. So let's take a look at some of the learnings that you're going to have to go through in order to effectively communicate and actually get your program in place. So first thing, let's get back to some of the basics. If you're going to communicate on a large scale, how does information actually flow through your organization? Before you try to swim upstream and go against how things normally go, how does information go through right now? Is it organized really well to where you have one person that you can go to or really direct lines to make sure that the information goes out? Or is it kind of a jumbled mess with a bunch of dotted lines where you got to get a hold of this person and that person, and oh, I forgot about this person over here? It's probably a mixture of both, where you're going to have either some departments or some facilities or even some divisions that are structured differently. So you're going to have to understand the structure in order to be able to communicate effectively. One example would be, if you look inside a typical facility, the maintenance department and how it's structured and communicates internally is going to be different from the operations department. They're going to be structured and communicate differently themselves. That's probably part of the reason why they never get along. But that's why you want to make sure that you stop and look at how the information flows so that you can make sure you optimize your communication. And then from there, develop your communication plan. And when I say develop the communication plan, I mean actually sit down and physically write it out. Write out your communication plan. That way you can go back and review it at a later date and adjust it accordingly. And we're going to take this back again to some of the basics. This is what everybody learned as they were going through English back in school. You got to put down who, what, when, where, and why. Who needs the information? You could list names, but you could also say, okay, so plant managers, EHS personnel, engineering, the maintenance team, the actual electricians or maintenance technicians. These are the people that I need to communicate to. What information actually needs delivered to each of those persons to make sure you're getting the right information, because it's going to be different depending on the job that they do. When will the information be delivered? Is this something that's going to go out on a monthly basis? Is it going to be a quarterly or an annual update? Or is this something, as something comes up, I'm going to get it out to them? Where will each person receive the information, or how will each person get the information? Is this something that there's going to be a centralized website, say a SharePoint or another centralized location that somebody needs to go to get the information? Or is this going to be part of a report, a conference call that's going to be reoccurring, some sort of training event that they're going to call into, a webinar? How are they actually going to be able to get the information? And then make sure you actually hit on why the information is important and why it applies to them. That way they can kind of relate it. It's not just something that's just coming down the pipe and hitting them. So as you do, make sure to take into account as well that there are going to be different levels of the organization that you're going to have to talk to. So when you're looking at, okay, say a maintenance technician, they're going to need the most detail. They're going to be the ones with their hands inside equipment directly exposed to these electrical hazards. So you're going to need to make sure that you probably give them the most detail. But when you talk to them, what do they want to know? They're going to say, just tell me what I need to do my job. That's typically what they're going to say. But there's going to be a lot to that. So how do you make sure that you communicate to them so that it resonates with them? A lot of times I look at it and say, you got to give the why. Why does this apply to you? Why do you have to wear your gloves? Why is PPE so important? Why do you have to fill out your job safety plan. What's the job safety plan going to do to you? If you give them the why behind it, it's more likely to resonate with them, and they're more likely to remember it in their day-to-day tasks. When you look at a plant manager, they're more than likely not going to be out there actually opening up equipment and being exposed to electrical hazards. So you may not need that amount of detail, but there's still a lot of other factors that they're going to need to know. How this affects the plant and some of the operations in it, but also, okay, what is this power system study thing, and why do I need to pay for it? Why do I need to make sure that it's actually budgeted properly so it actually does get done, paid for, and how do we follow up with it? So there's going to be other aspects that's going to apply to them that you need to make sure that you touch on. And then if you look at somebody in a corporate role, they're going to be looking at, again, they're not going to be actually out opening up equipment, but they're going to need to understand some of the effects and how some of the work and processes are going to affect operations and scheduling within the plants. They're going to need to know that, hey, you know what, we're going to need to take this machine down for a day in order to make this repair on it. Hey, we're going to need to take the entire plant down for a day, a few hours to be able to perform this maintenance act. That way we actually maintain our equipment properly. Well, that's going to adjust some of the operations and some of the scheduling that they're going to need to know and do. So as you come through, just a couple more call outs on the communication. Make sure you're giving the why. That helps give everybody a little bit more direction, and it doesn't come across as just another program that you're trying to shove down our throats. A lot of times there's a lot of things that come through. Giving them the why behind how it applies to them and why some of the requirements are there is important, but also give them the why as to what's changed. What's kind of driving these new requirements? Is it the fact that your organization had an incident or even a close call that kind of caught everybody's attention and made them dive into some of these requirements a little bit differently? Is it because maybe you're doing an annual review of the program and you realize that different parts of your electrical safety program really aren't quite adequate where they need to be? So that's really what's driving some of these changes, and make sure you communicate that out to them, and people seem to really respond to that a little bit more than just a, okay, well, here's some of the requirements, there you go. Make sure that you're prepared for questions, which again, that's not an earth-shattering comment. If you put in a new program, you're going to get a lot of questions, but you're going to get a lot of questions and a lot of very difficult questions, which personally, I love when I get asked something I've never been asked before. One of the reasons that I love it is because it forces me to look at the program in a different way. I've never thought about it that way because I've never had the question asked. So I need to look and see how some of the requirements we have in place can incorporate this new situation or this new structure or something like that. So it helps me make the program actually stronger by looking at it in a different light. So be prepared for it. You're going to get a lot of questions, especially from the maintenance personnel or the electricians out on the floor, because they're the ones that understand the hazards probably the best because they deal with them every day. So you're going to get a lot of questions, especially from them. And then don't be afraid of repetition. Don't be afraid of repeating yourself. As I look at this every day, I look at the program, I go through, I communicate to a lot of different groups. I often feel like I'm repeating myself. And even some people that I know have been through some of my communications and trainings multiple times, I've mentioned it to one person. They said, I feel like I'm repeating myself. And they said, you know, I've went through this a number of times. Each time I pick up on something different, so please don't stop. Each time I go through, there's something else that I missed last time that I go, oh, wait a minute. Oh, I forgot, how's that apply to this? And they think about it different ways, and it helps them strengthen their understanding of the program by just that little repetition. There's a lot to an electrical safety program, so that repetition really helps. And then continuity, electrical hazards should follow the same requirements. If you have two facilities, whether they be a steel mill, a paper mill, a bottling plant, a butter plant, a refinery, a concrete facility, it really doesn't matter. Electrical hazards are electrical hazards, and they need to follow the same processes and requirements for determining and dealing with the hazards. You have your shock hazards and your arc flash hazards, and you should have the same set of requirements around those when it comes, again, to determining and dealing with those hazards. When it comes to that, a lot of that driving that continuity, especially between facilities, is looking at effective communication. Your communication plan and making sure that you get the same information out to all facilities. You know what, did I miss a plant manager? Did I miss this group that's actually inside this facility? To make sure that you're effectively getting them the right information. Training and processes, how can we standardize some of the trainings that people take so that everybody receives the same message? Is there a way that way it's not, oh, this person's going to go to training here, this is a different vendor over here, this is a completely different one. Now they're getting some mixed messages. How can we help standardize that process? And then third is standardizing terminology to make sure everybody's in fact speaking the same language. Not actually the same language, especially if you're a global company, but I mean, they're using the same terminology. Couple examples is when I first started looking at this, just the thought of electrical work was something that a lot of people didn't really, there was a lot of confusion on. Well, is that electrical work or is this electrical work? Well, that is, but this isn't. Well, we standardized on the definition from 70E of if you're contacting something intentionally, if you're touching it on purpose and it's energized, you're working on it. So that got rid of a lot of that discussion of whether it was electrical work or not. And then from there, we can move on to especially the definition of the word exposed. Are you exposed to it? If you're exposed to it, or as 70 defines it, capable of inadvertently contacting, if you can touch it on accident, you're exposed to it, you have to protect yourself from it. Whether you're actually touching it or not, you're exposed to it. So that really helps standardize some of the processes to get people kind of looking at it in the same way. So you want to make sure for metrics, you're going to have the metrics to really help identify where your issues are and kind of drive your program forward. To be able to find out which metrics to look at, really stop and think, okay, what concerns you the most? What really keeps you up at night when you're looking at putting this in place? I know for me, we had the program built and I'm looking at going, man, how am I going to get everybody trained? We have a whole bunch of people. How are we possibly going to get everybody trained? Well, okay, well, there's our first metric, training completions. Then you got to look at, okay, what kind of data do we need in order to actually identify the data to actually support our metrics? A lot of people, they go out and they take the 8-hour training class, they come back with their certificate and they hand it to their supervisor, and their supervisor takes it and files it away. There's no possible way for me to be able to use that data to be able to support any type of metric because it's not tracked anywhere. So what do we need to do? We leveraged our learning management system internal to our organization to be able to take those, upload them, track them, put out who's required to take the training this year, which training it is, when your completions happen, any test scores that are available, certificates of completion. So a lot of that then goes into this system. Now I can use that data to actually report on and support my metrics. And with the reporting, you want to make sure that you're making the information simple to digest. So again, I use that learning management system. I just dumped it all, my first attempt, I just dumped it all to an Excel spreadsheet. I formatted it, made it a lot easier to look at. Ways you can go ahead and filter based off of location, training, person, division, all that kind of stuff, and send it out. And it really didn't go over very well. It's just too much information there. Nobody's going to go through and just look line by line at the report. So I had to actually go ahead and simplify it. So I created another page on my second attempt and really organized it by facility. Okay, here's facility A. Here's how many people are required to take the training. Here's how many people have completed it, along with your completion percentage. So then you can then compare how you're doing with your training compared to other facilities. You can also, as an overview, look real quick to say, hey, I thought we were done, but it says here that there's still 4 people that need trained. So let me go and follow up on that. And making that information a little bit simpler to digest, I got a lot better response on it. So once I have the information, you have the metrics, you have the program in place, everything's going and you're moving forward, you have your communication going, you want to make sure that you're actually reviewing your program and actually have regularly scheduled reviews as part of your electrical safety program. Because you don't want to develop this great program, put it out there, and then just let it sit there and pretty much wait for either an incident to happen or something like that, whether it be an injury or something worse, to where you actually go back at that point and say, okay, well, where was the miss? Oh man, I see that, yeah, our training really, that's not the way we do it anymore. We have a different system, we have different processes. It should have been updated on a regular basis. So you want to make sure that those reviews are actually part of your electrical safety program. And with that, making sure you're looking at the different elements of your program and the processes there. Are the processes actually being followed? Are the processes even understood? Going through, and people are going to come back and say, what's this energized work permit? When do I need to fill it out again? And you're going to get those, but how can you make sure that you get that information out to people? And then look at your communication plan. If you have your communication plan actually documented, you can go back and adjust that accordingly. Maybe there's a new group of people that when you wrote the program, the communication plan is now in place that really is just being missed right now. Let's add them to the communication plan. Then as you make any updates, you can use your communication plan to actually get it out to the right people. And then from there, what your metrics that you're using, what are the metrics actually telling you? Are they giving you the information that you're looking for? Are they giving you the areas to focus on? Okay, well, we see that it seems we need to focus some of our training in this area because of what our metrics are telling us. Or do you see some issues with the metrics? Or are there new ways to actually, new technologies out there to be able to actually gather the metrics and the data differently? So as we move forward, it allows you, the reviews allow you to adjust and improve and really make your program better. We want this to be a living, breathing program and not something that you develop and put on a shelf and everybody's just supposed to do. It's got to be a living, breathing program that you're actually adjusting. So in summary, the electrical safety program is really there to expand the understanding of electrical safety. How do we get everybody to understand electrical safety better and understand the role that they play? And then from there, you can help drive improvement and further the electrical safety culture within your organization. In doing that, you're going to want to make sure you understand the basics of electrical hazards and the requirements by OSHA and 70E. What are some of the key elements for your program that you're going to put into your electrical safety program? Making sure you're communicate an effective communication plan. Develop an effective communication plan to get the right information to the right people. And then from there, once you have it in place, make sure you're actually going over and reviewing it, really to improve the overall effectiveness of the program. Thank you.